Here we will discuss this gap method of combination or probability in a way you have never seen or read.
This is the only video on YouTube you are going to find. So dedicate just 10 min, and you will never forget what you had learned.
Let us understand the problem first. We have a row of 10 trees, and a person is going to choose 4 of them randomly. Our goal is to find the probability that none of the selected trees are next to each other. This means that we don't have any idea about which 4 trees would he choose to cut from these 10 trees. He freely chooses 4 trees. It is combination problem because the order at which trees are chosen doesn't matter. It is similar to calling friends to go for a movie. Whom we call first and result is same for friends. Then we number the trees from 1 to 10. Now we observe the examples of possible occurrence of outcomes and favorable number of outcomes. This is an example where 4 of the 10 possible trees are included in the outcome. The specific arrangement doesn't matter. Any group of 4 trees from the total of 10 is valid. These examples illustrate the 4 trees that are part of the potential outcomes. In this scenario, any combination of 4 trees from the total set of 10 is considered regardless of their adjacency to one another. To calculate the total number of favorable outcomes, we will first analyze some examples. This process will help us identify what constitutes a valid outcome, allowing us to then determine the final count. Thus, to find the total number of favorable outcomes, we'll start by using examples to define a valid result. Then, we will calculate how many of those results are possible. The objective is to determine the number of ways to select 4 trees from a linear arrangement of 10 trees, with the constraint that no 2 selected trees can be adjacent. In this context, a favorable outcome is defined as any selection that satisfies this non-adjacency condition. Let us discover all such favorable possibilities. To identify all possible outcomes, we begin by choosing 6 trees that will remain uncut and placing them on 6 designated green slabs. These slabs represent the positions reserved for the uncut trees, although we do not yet know which specific trees will occupy them. Next, we insert spaces between each of the green slabs, as well as at the beginning and the end. In these spaces, we will place yellow slabs. The purpose of these yellow slabs will become clear shortly. Now we mark these yellow slabs, numbering them. The arrangement itself solves the problem. We will place the 4 cut trees on yellow slabs, which are already separated from one another by green slabs. Because of this natural spacing, simply choosing any 4 of the 7 yellow slabs automatically guarantees that no 2 cut trees will be positioned side by side. That means we will place the cut trees on the yellow slabs and the uncut trees on the green slabs. Since we have only 4 trees to cut, we select any 4 out of the 7 available yellow slabs. Because there is always at least 1 green slab separating each yellow slab, placing the cut trees on these yellow slabs ensures that no 2 cut trees are ever side by side. We have not yet decided which of the 10 trees will go onto the green slabs and which will go into the yellow slabs. However, we do know that trees placed on green slabs will remain uncut, while those placed on yellow slabs will be cut. Since we are cutting exactly 4 trees and placing them onto yellow slabs, we must select any 4 out of the 7 available yellow slabs. The number of ways to do this is calculated using the combination 7C4. Let's explore the meaning of the combination formula 7C4 more closely. Here, the number 7 represents the 7 available yellow slabs, which we label as follows: 1, 2, 3, 4, 5, 6, 7. We will select 4 numbers from the 7 available. These 4 numbers will serve as a guide to determine precisely which trees are assigned to the green slabs, meaning they'll remain uncut, and which trees will occupy the yellow slabs, indicating they'll be cut. By choosing these 4 slabs, we establish a clear arrangement that distinctly separates the trees into those that stay and those that must go. Let's understand what this formula truly means. It takes the 7 yellow slabs as its starting point, and from these 7, it identifies every possible combination of 4 yellow slabs. Importantly, the order in which we select these 4 slabs doesn't matter. The formula simply finds all unique groups of 4 slabs that can be chosen. Let us now visually explore some of these possible outcomes to better understand the concept. One possible outcome is that we select the 4 yellow slabs labeled as 1, 2, 3, and 4. This specific choice means that these 4 slabs will hold the trees to be cut, clearly distinguishing them from the uncut trees, which will occupy the remaining green slabs. This arrangement illustrates just one of several potential ways we can assign the trees to their designated positions. Similarly, another possible outcome is selecting the yellow slabs numbered 1, 3, 5, and 7. This represents a different way of choosing 4 slabs out of the available 7 yellow slabs. This particular combination determines exactly which 4 trees, out of our original set of 10, will be cut. Each different selection of slabs provides another unique arrangement, clearly specifying which trees will remain standing and which will be removed. Other examples also fulfill the same purpose. The only difference is that each new selection of 4 yellow slabs identifies a different group of 4 trees from our original set of 10, indicating precisely which trees will be cut. Thus, every distinct combination of slabs provides us with a unique and clear scenario regarding the arrangement of trees that will remain and those that will be removed. Each possible combination precisely identifies the 4 specific trees to be selected for cutting from the original group of 10, a process we will verify momentarily, and there are a total of such 35 varieties. Consequently, each resulting combination uniquely identifies the 4 particular trees for cutting from the 10. The validity of this selection process will now be confirmed, which means each of these combinations precisely identifies a unique set of 4 trees selected from the original list of 10 that are designated to be cut. We will soon verify these specific selections in detail. Let us re-examine and explore this entire process with a fresh perspective. The goal here is to delve into the 35 distinct outcomes generated from the 7 choose 4 combination, understanding how they yield a selection of 4 trees to be cut, ensuring that none of the chosen trees are adjacent to one another. Here, once again, we've seen how 7C4 takes 7 numbers as input and generates all the possible combinations of 4 numbers. Altogether, this results in 35 distinct groups, each offering a unique selection from the original set. Here's a complete list of all 35 possible selections. Each selection has 4 numbers, and each number shows a tree that should be cut down. We haven't yet explained how these 35 different selections help us know which trees to cut. Each selection shows us a way to choose 4 trees so that no 2 of them are next to each other. Now we will show how these selections follow the rule and help us find the right trees to cut. Let's look at some examples to learn how to find the trees we need to cut. Let's take a closer look at 5 examples first. Out of the 35 selections, we will pick 5 to see how they help us choose the right trees to cut. These examples will show us how the selections give acceptable choices. First, we view 1, 2, 3, 4 selection. Since we are told to keep only the 4 yellow slabs marked 1, 2, 3, and 4, we remove the other yellow slabs marked 5, 6, and 7. After removing the 3 yellow slabs we don't need, we are left with 10 yellow slabs. Now we place these 10 slabs at the bottom, one under each of the 10 trees, from left to right. Since the trees numbered 1, 3, 5, and 7 are standing on yellow slabs, these are the trees we will cut. It looks like none of them are next to each other, which is just what we want. Now let's look at the selection 1, 3, 5, 7. We want to find out which 4 trees this selection tells us to cut. Just like before, we will keep the yellow slabs marked 1, 3, 5, and 7 and remove the other yellow slabs. Now we will follow the same steps as before. We have 10 slabs left, and we will use them again, placing them at the bottom one by one. And we will place our 10 trees onto the slabs from left to right, just like before. So we are told to cut the trees numbered 1, 4, 7, and 10 because those are the trees standing on the yellow slabs. Next, we look at the combination 2, 4, 6, 7. So we remove the other 3 yellow slabs marked 1, 3, and 5. Then we place the remaining 10 slabs and slide the 10 trees onto them, one by one. So in this combination, the trees numbered 2, 5, 8, and 10 will be cut. Interestingly, none of them are next to each other. The trees numbered 2, 5, 8, and 10 will be cut. Interestingly, none of them are next to each other. Now eventually we will observe the combination example 2003, 4, 4, and 5. We only keep the yellow slabs marked 2003, 4, 5 and remove other, and then we slide down the top list of 10 trees to stand on these 10 slabs respectively. Therefore, this list specifies the selection of 4 out of 7 yellow slabs, which in turn determines the 4 non-adjacent trees to be removed from the original set of 10. Therefore, this list shows us how to choose 4 yellow slabs from a total of 7. These chosen slabs help us figure out which 4 trees to cut down. Since the trees will be placed on these yellow slabs, the ones that land on the selected slab are the ones to be removed. This method makes sure that no 2 trees we pick are standing next to each other among the 10 original trees. Thus, this way, 7C4 provides all possible favorable cases, i.e., 7C4 produces all possible selection of 4 trees such that none is adjacent to each other. If you'd like to understand such problems in a simple and visual way, we kindly invite you to subscribe to the channel. Your support means a lot.
If you want to learn math intuitively and visually this way, and then please consider subscribing the channel.